Roots of polynomials for a cubic. I'm going to go through this in a couple of different ways. First of all, good old roots of polynomial formulae. We've got the sum of the roots is going to be minus b over a. Let me just add that this is a, this is b, this is c, and this is d. Then the sum of the pairs of roots being multiplied together is c over a, and then the three of them is minus d over a. In this case, there is no sum, that is just alpha, beta, gamma. So I can go straight into it. Alpha plus beta plus gamma for the cubic. By the way, these are like generally true, which is why I always like to write them down, because then I can apply it to a quadratic or quartic or quintic, etc. if you wanted to. Okay, so alpha plus beta plus gamma is going to be minus 3 over 5. Alpha beta plus beta gamma plus gamma alpha is c over a, that's minus 4 over 5. Alpha beta gamma is then minus 7 over 5. And we want to then find out an equation with these roots. So what we actually want, it's worth writing this down, is so find minus b dash over a dash equal to alpha plus beta plus gamma plus alpha, the sum of all of those. This is actually very quick to do because it's just going to be 2 alpha plus beta plus gamma, which is going to be minus 6 over 5. Like that with that one. And then c dash over a dash is going to be, okay, this obviously this is going to get a bit more awkward. Alpha plus beta, now we're timesing them in pairs, times beta plus alpha plus beta plus alpha, sorry, gamma. Sorry if I said any of these wrong. Gamma times, times gamma plus alpha plus gamma plus alpha times alpha plus beta. Okay, I will work this one out. I think this is going to be the most complicated one. Let's expand the bracket. I'm going to get alpha beta plus alpha gamma plus beta squared plus beta gamma. Then I'm going to get another, it depends, you can either write them all out, or you can start to try and like speed things up. If I do beta times gamma, actually I can put a 2 here, and then beta times alpha, I can put a 2 here, and then I'm going to get a gamma squared and then another gamma alpha, so I can put a 2 there. And then finally I've got alpha gamma, actually I can change this to a 3, gamma beta, alpha squared, alpha beta. Okay, so actually you can do it quite quickly using that idea. This is going to give us alpha squared plus beta squared plus gamma squared plus 2 lots, no, not 2, 3 lots of alpha beta plus beta gamma plus gamma alpha. I won't figure that out quite yet. So this one's a little bit, we don't have the sum of the squares. So what I'm going to need to do is work that out. Let's take alpha plus beta plus gamma and times it by itself. Because then I'll get alpha squared plus alpha beta plus alpha gamma plus beta squared. Oh yeah, and beta alpha, so I'm going to get 2 of them, and then beta gamma. Then gamma alpha, so I've got another one of them, gamma beta, another one of them, plus gamma squared. So therefore, alpha squared plus beta squared plus gamma squared is going to be alpha plus beta plus gamma all squared minus 2 lots of alpha beta plus beta gamma plus gamma alpha. Okay, you might learn some of these formulae, but you don't have to. It's take a little bit longer. So we've got minus 3 over 5 all squared here, 9 over 25. And then I'm minusing. I mean, to be fair, I could sort of combine them all. Yeah, maybe I should do that. So therefore, C dash over A dash is going to be alpha plus beta plus gamma all squared. Then I'm adding 3 of these, but then I'm minusing 2 of them. So I'm just going to get alpha beta plus beta gamma plus gamma alpha. Okay, and that's kind of the formula that you might sort of learn in this situation. Um, nah, I wouldn't bother. Okay, and then we've got minus 3 over 5 all squared, so 9 over 25, plus the pairwise sum, that's minus 4 over 5. Minus 4 over 5 becomes minus 20 over 25, which gives me minus 11 over 25. Let's just keep track of this then. So I've got C dash over A dash, and I've got, remember, minus B dash over A dash. That just leaves me with minus B dash over A dash, which, remember, that is when I multiply them all together. So I'm going to get alpha plus beta times beta plus gamma, gamma plus alpha. This gives me alpha beta plus alpha gamma plus beta squared plus beta gamma. Alpha beta gamma plus alpha gamma squared plus beta squared gamma plus beta gamma squared plus alpha squared beta plus alpha squared gamma plus alpha beta squared plus alpha beta gamma. Okay, so now I'm going to factorize an alpha out, not from everything, but from this term, which will give me alpha gamma, this term, which will give me alpha beta, and one of these, which will give me beta gamma. And then I'll do the same with beta to this one. So I'll get beta gamma, this one. So I'll get beta alpha, this one. So I'll then get alpha gamma. And finally, I'll do the same with gamma. So I'll get alpha gamma plus beta gamma. Now I'm missing this other term. So what I'm going to do is include it, beta alpha, and I'm going to need to minus an alpha beta gamma as a result. So then I can actually factorize out the alpha gamma plus beta gamma plus beta alpha, but be left with alpha plus beta plus gamma minus alpha beta gamma. Look, it's pretty epic, but you've got to practice these. And now we're back to things that we know. We've got the pairwise ones all the way back up here. We had minus 4 over 5 times by minus 3 over 5. And then I've actually forgotten what the other one was, minus 7 over 5. So it become minus 7 over 5, so plus 7 over 5. So that gives me 12 over 25 plus, times this through by 5, 35 over 25, which gives me 47 over 25. Ooh, okay, we've got everything we need now. Just got to write them down again. So minus d dash over a dash we've just worked out. But I also had minus b dash over a dash and c dash over a dash to write down. So c dash over a dash was minus 11 over 25. B dash minus b dash over a dash was minus 6 over 5, which I can now write as minus 30 over 25. Put them all over a common denominator because we are basically there. Let a dash equal 25, which implies b dash is going to equal 30. So then I get, when I put it in, minus 30 over 25. C dash is then going to equal minus 11, and d dash is going to equal minus 47. So hence 25x cubed plus 30x squared minus 11x minus 47 equals 0. This will have roots alpha plus beta, beta plus gamma, gamma plus alpha. It's pretty epic, that. The more you practice, the easier it will become because you're sort of ready to look out for these things. Because the last one where we had to kind of do that factorization, that was pretty awkward when you've never seen that before, but ideally you will have. Now I'm going to go through one other method. It's a substitution. And you might think you can't do a substitution because different things are happening to each root, but you can, in fact. We're going to let w equal alpha plus beta plus gamma minus x. This will actually necessarily give me the required roots because when x is alpha, w will be beta plus gamma. When x is beta, w will be alpha plus gamma. And when x is gamma, w will be alpha plus beta. It all works out. That means that x is going to equal w, wait, not w, x is going to equal alpha plus beta plus gamma minus w. And now we just need to work out what alpha plus beta plus gamma is. But actually, we did that like right at the start, and you can do it again if you wanted, but it's going to be minus 3 over 5. So actually, that is our substitution. I think it's a good idea to factorize the minus out. This will make subsequent calculations a little bit easier. Okay, now we can sub in. So I've already got x. Now I want to work out x squared. And that's why I can just ignore the negative now. I'm going to get w squared plus 3/5 w plus 3/5 w. So that's 6/5 w plus 9 over 25. There we go. And then x cubed just multiply it all together again. And yes, there's fractions going on, but actually it turns out this is so much quicker than our original method. So it's one to be aware of. It's not just like for fun, this. Let's find that out. Gives 3/5 w squared plus 18 over 25 plus 27 over 125 plus w cubed plus 6 over 5 w squared plus 9 over 25 w. Bring this together, I got w cubed, 3/5 and 6/5, I've got 9/5. I think I missed a w out, didn't I? Ah, there it is. Okay, easily done. Plus 27 over 25 w plus 27 over 125. Okay, I'm now ready to sub it in to here. So I've got 5x squared. So I'm going to times the minus out and by 5 at the same time. I'll get minus 5. So therefore, minus 5w cubed minus 9w squared minus 27 over 5w minus 27 over 25 plus 3x squared gives me plus 3w squared plus 18 over 5w plus 27 over 25. Then I'm minusing 4x. So actually it's just going to become a plus here, and I'll get plus 12 over 5 plus 4w, and then plus 7 equals 0. When I did it, I times through by 25 at no, I didn't. I think I cancelled these out and then I times through by 5. I think I'm just going to keep going though, to be honest. So minus 5w cubed. That with that one, right? Let's deal with the w squareds. So I've got minus 9 and plus 3. That's going to become minus 6w squared. Then minus 27 plus 18. That's going to give you minus 9. This is actually 20 over 5. So minus 9 plus 20 is 11. Plus 11 over 5w. And then 7 is actually 35 over 5. Plus the 12 gives me 47 over 5. And finally, just going to multiply through by 5 at this point, and also swap the signs around, so multiply through by minus 5 essentially. I get 25w cubed plus 30w squared minus 11w minus 47 equals 0. Same answer as before. A little bit awkward with the fractions, but I've done it all without a calculator, so of course, if you use a calculator, less likely to make a mistake. Yeah, but you can see we get the same as before without all of that kind of roots of polynomials. So, but make sure you're aware of both, I'd say. Like for any situation, think, can we use a substitution or roots of polynomials? Practice both and you'll be okay. Well done.